Hi, I'm Karl Burkart, CEO of the Nature Data Lab, which is dedicated to unlocking the power of science and technology to accelerate the global nature positive transition. By way of a quick intro, in the past several years, we've led or funded 44 papers supporting over 100 scientists doing critical research on a wide array of topics, covering ecosystem condition, biodiversity, and climate change, with the goal of producing actionable data that can be used in decision making, particularly in funding allocation. What do we mean by nature data? On our website, Nature Data Lab, we've got a more detailed explanation, but it's helpful to quickly show you this as a reference. Data has four main phases of its life cycle, if you will, starting out with raw data received from instruments like audio sensors, drones, or satellites, which through processing, cleaning, and formatting become measurements. These measurements are transformed through modeling into information that can then be put to use inside decision support systems to take actions in the real world. For example, financing a nature restoration project. Once implemented, monitoring and verification systems track the project over time, producing another cycle of raw data that can then inform future projects. The Nature Data Lab is focused on the lower half of that chart, broadly defined as informatics. We organize work in three main programs: primary research, which provides grants and technical support for scientists focused largely on ecological mapping. These data provide essential inputs for our applied technology program, which develops and manages data products to inform decision making, including the global safety net, which I'll show you in just a minute. Statistics produced by the GSN and other efforts then inform our Earth Economy program, which works to scale public and private finance for nature. I decided to launch a lab focused specifically on nature data because of the urgency of the moment. Over the next 5 to 10 years, we need to marshal an absolutely massive amount of capital to protect and conserve nature at scale, from about $200 billion today to an estimated $1 trillion per year, according to the new Paulson report, Financing Nature. A lot of efforts thus far are focused on the private sector, which is great, but we really need to be looking at government flows of capital as well. And that takes us to our, I guess, provocative theme for this session at the London School of Economics, the concept of nature-adjusted GDP, tracing the wealth of nations back to the source. This theme explores how nature data could potentially change the outlook of countries at the macroeconomic level, intercepting one of the largest flows of capital on the planet, sovereign debt. Going back to 1776, when Adam Smith wrote his treatise on capitalism, he certainly wasn't thinking about this lone wolf in Yellowstone, California, as having anything to do with the wealth of a nation. Back then, there were only about 850 million people on Earth, and nature was seen as an endless well of resources for the taking. Of course, at the time, no one understood just how valuable ecosystems were and the enormous importance of the iconic species that manage them. It turns out that wolves are indeed very valuable, which we learned after their complete extermination from the Yellowstone ecosystem and the trophic cascade which then ensued. Within decades, the entire ecosystem started to collapse. Without wolves, coyotes and deer ran amok. The former decimated beaver populations, the ecosystem engineers of the river, and deers with no serious threats could now descend to the riverbanks and devour the abundant vegetation there, leading to major soil erosion, which then disrupted fish spawning and so on. It wasn't until the wolves were reintroduced in the mid-1990s that the ecosystem began to heal. Most people still don't get it that without the intricate web of life and the myriad of species that make it all work, none of us would probably even be here today talking about this very topic. What you see here is the latest version of the One Earth climate model, which we developed with a cross-disciplinary group of scientists and engineers. It shows that we can still achieve the long-term 1.5 degrees Celsius goal of the Paris Agreement by transitioning our energy systems, but equally important are those light blue and green areas at the very bottom of the chart. These show the annual background removal of CO2 by the world's land and ocean carbon sinks, which absorb about half of our emissions every year. Without these regulating functions of nature, we'd basically all be toast by now. So we need to secure and properly finance these carbon sinks. And as you can see with the color bars below the zero line, there's also a very large potential for additional carbon dioxide removal from natural solutions. We have fairly detailed models for the median potential of these nature-based pathways. According to our research, we can remove approximately 169 billion tons or gigatons of carbon dioxide through reforestation and forest management by 2100, about 45 gigatons from coastal restoration, and 67 gigatons from grassland restoration and silvopasture. There's some new research also that shows the presence of large herbivores like bison can actually increase that amount. And we can even estimate the additional climate mitigation potential from investing in specific species. Two papers show that restoring Pacific and Atlantic whale populations could result in an additional 32 gigatons removed, and restoring African forest elephants to their original levels could remove another 11 gigatons. The economist Ralph Chami led much of this research, who we'll be talking about in a minute. If we were to attach a price tag on the four slides I just showed you at $20 a ton, it would total about 6.5 trillion in value. Those are just a few examples of the role nature plays in regulating our climate, and climate regulation itself covers just 2 of 45 different types of ecosystem services provided across terrestrial and aquatic domains. The latest estimate is that the sum total of these ecosystem services is worth roughly 58 trillion, underwriting approximately 55% of the global economy. But of course, nature does not receive any compensation for this, which is due in part to how we account for GDP, gross domestic product. The timing for our session is great because just recently the UN put out its first big report from the Beyond GDP high-level task force called Counting What Counts. In the report, they make a case for incorporating new metrics to track how countries are really doing beyond just a simple GDP per capita metric. Here are two examples they provide. On the left, health outcomes in North America have recently dramatically declined despite increased GDP per capita since 2020. And on the right, GDP is rapidly increasing in East Africa, but this is at the expense of massive land degradation, which could result in an increase in poverty in the future. Clearly, GDP is not a great measure of the health and well-being of a society. Many ideas have been proposed to fix this metric, going back to green GDP, introduced by SEA, the UN System of Environmental Economic Accounting, which had a moment back in the early 1990s, but was shelved due to country backlash. Since then, many other proposals have been made, from donut economics, global ecosystem product, gross national happiness, a new one, the Nature Relationship Index, the Human Development Index, Better Life Index, the Index for Sustainable Economic Welfare, and Global Peace Index, to name a few. All of these are what we might call side-along metrics. They don't actually touch the core GDP metric itself. Though these ideas are beautiful and useful, they really weren't created from the perspective of a financial planner sitting in a country office or at a central bank who really only cares about answering one question: is my investment going to pay off? Countries need access to capital to grow, and how much capital they can get and at what lending rate is determined by this one equation, debt level. Countries need to increase their growth rate, G, in order to lower their interest rate, R. But here's the problem. Some of the most important biodiversity areas and carbon sinks are held by relatively low-income countries, some of whom have a very high R value. Protecting natural assets doesn't help them in the all-important debt-to-GDP ratio calculation. It's actually just the opposite. Converting or extracting natural resources quickly increases their cash flow, boosting G, which then reduces their cost of capital. In a sense, the equation at the heart of the global economy effectively incentivizes the destruction of nature, not its conservation. It's important to understand the sheer volume of the capital we're talking about, driven by the simplistic debt to GDP ratio. In emerging markets and developing economies, 157 nations representing 90% of the global population, sovereign bond issuances hit 4 trillion in 2025, bringing the total debt stock to 14 trillion USD, or 30% of GDP, the highest level since 2007, according to the Global Debt Report. This means EMDE countries will be spending close to $1 trillion per year just to service their debt. This system is not good, but unfortunately, it is how the world works. But what if there were a way to reduce the debt burden of low-income countries by putting nature on the balance sheet? This is the question addressed by an exciting new paper we're supporting exploring regenerative GDP, or ReGDP. Led by Ralph Chami, the aforementioned whale economist and former division chief at the IMF, a group of economists have worked out the quite complicated math on how to sort of hack the all-important debt level equation, injecting projected revenues from ecosystem services into economic growth calculations. This could quickly improve lending rates and thus the long-term economic outlook of EMDEs. As Ralph says, moving beyond GDP to ReGDP is not a symbolic shift. It is about aligning economic logic with ecological reality. And that alignment will define the next chapter of our economy. The new Chami et al. Paper models the ReGDP of the Bahamas, a heavily indebted nation with a 66% debt to GDP ratio. However, recently, marine biologists studying the behavior of sharks in the Bahamas, interestingly by strapping cameras to their backs as they swam around, discovered the world's largest seagrass meadow, which is roughly the size of Austria. Based on this asset, the economists can now accurately project future revenues from carbon, fisheries, and tourism, which dramatically improves the Bahamas' debt level calculation and thus its overall economic outlook. The ReGDP approach allows poor countries that are rich in natural resources to incorporate that wealth into their balance sheets. What does this mean in light of the 30 by 30 goal, protecting 30% of the planet by 2030? This target was recently operationalized as part of the UN Biodiversity Convention in Montreal a few years ago, and in some ways you could say it has kicked off a giant world game. Not sure if you are familiar with this term. It was coined by Buckminster Fuller. And in this context, it can be imagined as something like a race for nations to protect more of their natural resources, gaining a larger share of the 30% global goal. Some countries will do much better than others in protecting their critical natural assets. And like the Bahamas, those countries could be rewarded for healthy, functioning ecosystems through reduced debt burdens, saving them hundreds of billions of dollars over time. This sounds theoretical, but actually the global game is already underway. We've had major asset managers approach us for our national rankings in order to divide countries into tranches. These companies who buy sovereign EMDE debt are interested in assigning a lower risk status to the top performing countries, resulting in preferred interest rates on their bond issuances. Playing this out in one global scenario, countries with a higher ecological status could save as much as $750 billion collectively over an average modified loan duration of 6.5 years versus countries that continue doing business as usual. You can see that this could quickly become an enormous financial incentive for countries to strive to conserve and restore their ecosystems. We're currently working on a new paper on national ecological rankings. And for some quick background, this is part of our larger series of studies going back to the release of the Global Deal for Nature in 2019, which introduced the 30 by 30 target into scientific literature with 17 partner organizations. This was followed by the Global Safety Net, the first stocktake of natural lands at 1 kilometer resolution, and more recently, Conservation Imperatives, which identifies unprotected sites harboring rare and threatened species. These papers were very influential with over 1,300 academic citations, but we didn't do this just to put out science. We wanted to turn the science into action, so we created a data platform. Version 1 of the Global Safety Net, or GSN1, was the first to present areas of importance for biodiversity and ecosystem services on land, organized in 5 major ecological classes. And it was named a world-changing idea by Fast Company. With V2, we discovered that when dropping down to 100-meter resolution, we found there are many areas that are designated as important but have already been converted for human use and thus shouldn't be considered for conservation. On the left in coastal Cameroon, you see all the magenta or rare species areas that are no longer left. And on the right, the loss of habitat in the Colombian Andes. We were also reviewing other major attempts like the Nature Map led by WRI, which shows just how difficult it is to differentiate between natural and modified lands at a global scale. Both of these scenes, a village in Togo on the left and a palm plantation in Ghana on the right, should be solid black, representing converted lands. But you can see here they are counted as natural land. For V3 of the Global Safety Net, we designed a new process to screen out human modified land from ecologically important areas, utilizing a groundbreaking mapping initiative at the Nature Conservancy called HM90, which we also supported, documenting the history of land use change over time. All of these data are compiled and displayed on our new dynamic web application, GSN3. Giving you a quick look at the live beta here, there are three main views of the data compiled at 90-meter resolution. The first shows the five main ecological groups: rare species sites, high biodiversity areas, large mammal assemblages, intact wilderness, and climate stabilization areas. Clicking on any country displays statistics on the total extent of these natural land areas. And you can also see an inventory of these land areas by land cover class, showing different forest types, grassland and dryland, or wetland and freshwater, for example. Lastly, you can see the extent to which these areas of importance for biodiversity and ecosystem services, or AIBES, are protected or conserved, and the full conservation estate, including documented indigenous territories. The intersections of these datasets can be exported in a detailed analytics table, which allows you to see where the critical gaps in conservation coverage may be. We're working on a new paper that introduces a novel conservation status index based on these statistics, updated annually, which allows a comparison of how various countries are doing protecting their most ecologically important areas, which could also be used as input into ReGDP calculations in the future. So we do have a way to incorporate the wealth of nature into the wealth of nations, but it requires an ongoing investment in nature data, which we've laid out here. I'm at time here, so thanks for listening, and feel free to visit our website to learn more about the Global Safety Net and our Earth Economy program. Thank you.